All right, lesson 6-5, the remainder and factor theorems. So by the time we are done with this lesson, we are going to be able to evaluate functions using synthetic division and then decide if a binomial is a factor of a polynomial. And we're going to use these ideas in the next section to continue working towards solving polynomial equations. So problem 1, it says divide using synthetic division. So this is a review from an earlier section in this chapter. So remember, if we're going to use synthetic division in our little half box, we need the 0. So whatever we are dividing by, we set equal to 0 and then get the x by itself. So we would add the 3 to get positive 3. So the 3 is what goes in the box. And then we are just writing out the coefficients. And remember, if a coefficient or a term is missing, then we need a 0 placeholder. Now for this one, we don't need to worry about that. So we're going to use -3, 5, and 4. Again, first number always comes down, so -3. 3 times -3 is -9. 5 plus -9 is -4. 3 times -4 is -12. And 4 plus -12 is -8. Now before I put it back into the equation, we're going to go on to the second problem. So here it says to evaluate. And when I'm looking at this, we're evaluating for 3. So that means to replace all of the x's and simplify as much as you can. So -3 times 3 squared plus 5 times 3 plus 4. So again, power first. So 3 squared is 9. 9 times -3 is -27 plus 15 plus 4. So again, if we continue to add, -27 plus 15 is going to be -12 plus 4 is going to give us -8. Okay. So now I want you to notice the answer when we evaluated was the same as the remainder for our first problem. And notice our equations are exactly the same, and the 0 that we used was exactly the same. So that's basically what our remainder theorem says. It says if a polynomial p of x of degree n greater than or equal to 1 is divided by x minus r, then the remainder is p of r as shown above. Okay. So again, this is telling us if you are asked to either find the remainder or to evaluate, you can now choose between either method. So whichever one you like better, or whichever one is more convenient at the time. Okay. All right, so let's do a couple more examples. All right, so it says use synthetic division or synthetic substitution to find the remainder of p of x equals x to the 4th minus 5x squared plus 4x plus 12. Okay, so again, that's just telling us to use synthetic division with the 0 that it gives us, and the remainder is our answer. Okay, so -4 goes in our little half box. We have 1. We're missing the cubic term, so I need that 0 placeholder. And then -5, 4, and 12. All right, so 1 comes down. -4 times 1 is -4. Add to get -4. -4 times -4 is 16. Add to get 11. -4 times 11 is -44. Add to get -40. And then -40 times -4 is 160. And then we are adding to get 182. So our final answer for this problem is 182. Now make sure when it's like this that you do not change the sign. This represents the 0, so that goes in our little half box when we do synthetic division. I know it's hard to see, but that's a +3. So 3 goes in our half box. We're using the same coefficients, so 1, 0, -5, 4, and 12. 1 comes down. 3 times 1 is 3. Add to get 3. 3 times 3 is 9. Add to get 4. 3 times 4 is 12. Add to get 16. 3 times 16 is 48. And then add to get 60. So 60 is our final answer for this problem. Now, when it looks like this is the one where we set equal to 0 and get the x by itself. So negative 2 is the 0 that we have to use to find our remainder. So again, our coefficients are going to be the same since we're using the same equation. So this is 1, 0, negative 5, 4, and 12. 1 comes down. Negative 2 times 1 is negative 2. Add to get negative 2. Negative 2 times negative 2 is 4. Add to get negative 1. Negative 2 times negative 1 is 2. Add to get 6. Negative 2 times 6 is negative 12. Add to get 0. So 0 is our final answer for this one.